Hey everyone, welcome back to my YouTube channel. If you are seeing me for the first time, this is Santosh Poturaju. Today we are in application development to the deployment video course. If you missed the earlier videos, we spoke about the overview of the project, and also we gone through some videos like developing the one example application, and also covered the CI part, like a continuous integration part. And this video is more on the delivering that application to the Kubernetes cluster. So if you are interested in this video, please continue watching it. Or if you want to start from the scratch, you can go to my channel and then you can go to the playlist and you can start watching from the overview. Okay, all right. So as promised in this video, we are going to talk about a lot of things, to be honest, and I will just try to whiteboard it. So far we completed the application development. So we wrote the application, right? Okay, so far we completed app development. Once application development is completed, we committed the code to the GitHub, and then we use the CI process, which is GitHub action, and then we pushed that image to the Docker Hub. So here now the CI process, right? So in this video, what we are going to do is we are going to understand the stages for delivering this application to the Kubernetes cluster. Let's assume that this is the uh, Kubernetes cluster and how we are going to deliver this application to K8. There are a lot of ways to achieve this goal, but in this particular video, we are going to more focus on the GitOps methods. What is the GitOps methods, right? So let's talk about GitOps methods for a second. Then after we will talk about some of the tools. And GitOps is more like a, let's assume that once you complete the application development, you will commit all the code to the GitHub, right? So in the GitOps, the main principle of the GitOps is for any deliveries or for any actions you want to do, always your single source of truth is your GitHub. No matter what changes you want to make, you must make all those changes on the GitHub so that whenever you have to look back and then you will treat this code as the your source of truth, and from here you can do whatever the modification you want to do, or maybe if you want to integrate with something else you can do that. So in this particular scenario, our goal is delivering this particular application to the KH, right? So once our application code is ready, we are going to use some GitOps based tool, and then we are delivering that application to the Kubernetes cluster. So let's assume these circles are like some application pods, and let's say this is some app, and if I am looking for deploying that application to the Kubernetes cluster, let's say if I have replica set equals to 3, there will be some one active pod, and there are 2 replicas will be running for that particular application. So now we know what is a GitOps. GitOps is more like you will treat a GitHub as your single source of truth, and then there should be some tools which will be delivering this particular application to the Kubernetes cluster. The main and the popular one in this particular space is ArgoCD. And most of the people will think like Argo CD itself is a GitOps, but GitOps is the concept. This is the fundamental concept, and Argo CD is following the GitOps principles or GitOps fundamental concepts. So when it comes to the Argo CD, there are a lot of advantages comparing to some other tools. To be honest, as I promised in the overview course, we are not going to spend too much time on Argo CD, but we are going to learn Argo CD in depth in the Zero to Hero series. But I will just quickly go over what is Argo CD. ArgoCD is nothing but a GitOps based tool which is going to read the manifest files starting from the GitHub, and then it is going to deliver all the changes to the Kubernetes cluster. The main advantages are, let's say someone made some changes on the Kubernetes side, right? So once the application is delivered to the Kubernetes cluster, anybody, whoever has the access on this cluster, they can make any changes. Let's say I have my administrative level of access on this cluster, then I can make any changes, right? So those changes are called a drift, and any of these drift will be identified by the Argo CD, and then it will override all these drift configurations. How this is going to happen, right? So within the Argo CD, the very first advantage is drift. So when it comes to the Argo CD, it's a built on top of several components. Let's assume all these are some hidden components. When we deploy the Argo CD, we're going to see the some pods running in it. But let's assume that there are some pods running, and this pod is like always connecting to the my source. So let's say this is my application GitHub repository. This pod is always connecting to the this GitHub repository and look for changes all the time. This will happen continuously. Ideally, every 3 minutes. To be honest, every 3 minutes, this particular pod is going to get the latest status of the GitHub, and we call this status as the desired status. And let's assume that this pod is actually connecting to the my Kubernetes cluster. And this pod is responsible to monitor the actual state is running on the Kubernetes side. So this state is called actual state. So now GitHub's tool, this Argo CD, what it is going to do is this is going to compare the desired state, and let's say this is state 1, and then this is the state 2. The Argo CD is always going to compare whether state 1 equals to the state 2 or not. So what is the state 1 here? That is the desired state, and state 2 is the actual state. So if these two are equal, that means everything is healthy on the application side. But if this is not healthy, that means there are some changes happen either on the source side or on the destination side. Then immediately Argo CD is going to roll the desired state to the Kubernetes cluster. So let's say this is not equal, then that means Argo CD is going to deliver all the desired changes to the Kubernetes cluster. So what are the advantages? The very first one is whoever made any changes on the Kubernetes side or the desired state, GitHub, this GitOps tool, which is Argo CD, always look for the active changes, and then the responsibility of Argo CD is delivering all those changes to the destination cluster. The number two is, let's say, um, once I drop the application to the Kubernetes cluster, right, most of the CD tools are not going to do any monitoring activity, right? So let's say here somebody made some changes, and then the application, this Argo CD, is not going to monitor any health of the application. So here Argo CD is actually doing the health monitoring. So that's how it can deliver the active changes from the desired state to the actual state. What is the third advantage? So most of the tools will just drop the application to the Kubernetes cluster. There is another advantage of Argo CD is, let's say I drop one application to the Kubernetes cluster. For example, in our scenario, we are dropping the Django application, right? So let's say this Django application is delivered to the Kubernetes cluster. So right from the Argo CD, I can continuously look for the logs. So I can read all the logs and I can quickly verify whether my deployment went successful or not, and something like that. The number four, so ideally, if we need to adopt any continuous delivery tool, what we have to do is we have to integrate the tool with the Kubernetes cluster. Let's assume that this is one Kubernetes cluster, and let's assume this is some CD tool, right? So if we have to deploy any application from the CD tool to the Kubernetes cluster, we must also maintain that integration, right? We have to create the integration and then we have to maintain that integration. But when it comes to the Argo CD is natively running. This is Argo CD. Argo CD is natively running on the Kubernetes cluster. That means our back is already configured, and then we can also tweak it if required. But since Argo CD is natively running on the Kubernetes cluster, so there is no external integrations are required. And then it's matter of configuring the Argo CD with some GitHub so that we can start delivering some other application to the Kubernetes cluster. So it's kind of integration, the fourth point. There is no need of integration since this is running natively on the Kubernetes cluster. So I think we covered a little bit of overview on the Argo CD, but as I told you, this is not the very in-depth detail, but I believe this is going to give you some very high-level details on what is Argo CD. So the very first step for our lab exercise is before we spin up the Argo CD, first of all, we need to have the Kubernetes cluster, right? So in my laptop, I have a Podman. In your scenario, most likely you will be running with the Docker, or maybe you're also using the Podman. But ideally, both are same. So let's say you have the Podman or Kubernetes. So once you open the Podman desktop or Docker desktop, oh my bad. So either Podman desktop or Docker desktop, you can go to the Kubernetes cluster, and then it will give you some option to create the cluster. So nowadays, even Docker is also has native options like creating the client kind cluster. Kind is nothing but a Kubernetes in a Docker. So both the Podman and Docker, both desktops had this particular option. So once I create this button, I mean, once I click on that button, it is going to ask some details like what the name I want to call this particular cluster. And I just want to leave everything default. And once I click on the create, this is going to create the Kubernetes cluster for me. So I'm going to use this kind cluster as my Kubernetes cluster, and we are going to deploy that Argo CD first, and then after we can deploy the Django application what we created to this particular client cluster. I believe this is going to take another minute or so. But you got some idea, right? So if you're on the Docker desktop, go to the Docker desktop, look for the Kubernetes cluster option. Once you click on the Kubernetes cluster, it should had some option like create the Kubernetes cluster with kind or maybe kubeadm. So go ahead and provision the cluster. So once that is completed, you can go ahead and execute some kubectl commands. In that way, we can verify whether that cluster created or not. Okay, looks like the cluster is created. And now how I can verify it. So this is going to show us some information like, this client kind cluster is up and running and this is the name we given. But there is another way. So just go to the VS Code and the bash. I always prefer the bash terminal. And here just execute kubectl get nodes. And this is going to give us the list of nodes from this particular cluster. Since I created only a single node cluster, I have only one node which will work as control plane, worker, whatnot. It could be everything for me. Okay, all right. So now we have the kind cluster. It's time to go ahead and check out the Argo CD. And again, these instructions are pretty much documented. If I go back to this README, I have all those instructions right here. If you are interested in reading the documentation here, you can do that. Otherwise, you can also go to the official documentation, like Argo CD official documentation, and you can read the details over there. But I have all the shortcuts right here within the GitHub report. Okay, go to the Argo CD and then get started. And if you see here, uh, how we can install the Argo CD, right? So the very first command, the kubectl, uh, this kubectl is something like the interface for the Kubernetes cluster. So whenever I execute the kubectl command, this utility is going to execute some API calls with the API server, and all the actions will be performed. So the very first command here is creating the namespace. I think it's a good idea to create the dedicated namespace and then deploy those dedicated workloads. In this particular scenario, since we are deploying the ArgoCD, we are creating the namespace called ArgoCD. This problem, okay, you'll get ns, and this is going to is the namespaces. Now I have the ArgoCD namespace, and it's time to run another command. And basically, this command is going to pull the manifest. And let's go ahead and read this manifest you're interested in. But this manifest is more like the all the pre-steps and all installation steps, everything is compiled into a single YAML file. And once I apply this particular manifest file, this is going to create that Argo CD pods in my Kubernetes cluster. So let's go ahead and execute the second command. And there is no harm to run the first command because it's already there and it's going to throw out some error. But since I'm having some copy paste problem, uh, I just clicked on the copy button. Okay, if you closely see, there are tons of resources got created. Something like application set controller, DEX server. This is more like the authentication type of server. We will talk about that. So if you subscribe our channel, we are going to post a zero to hero courses, and during that time, we are going to talk about all these individual components, and we can also try out some external integrations like authentication integrations. There are a lot of stuff we can do, but I'm going to cover all those in a dedicated video series. Okay, now if I look for the pods under Argo CD, it's it's giving the status of the pods, and looks like everything is running right now. And just to tail the logs, if I want to tail the logs, I can do that. And this is the server. Then namespace is Argo CD. This is going to give the some messages. Okay, so far we installed, everything is good, and let's go ahead and read the next steps. So CLI, there are several ways to talk to the Argo CD. The most easiest one is get to the UI of the Argo CD, and from there we can complete all the action. Okay, all right. So it looks like this is the port forwarding command we have to execute. And I believe this is also documented in this README EMD file. Yep. So the kubectl port forward is already there. Okay. And now let's go ahead and port forward it. Okay, cool. So it looks like 8080. This is the port number, but we also need to have uh, the admin password. So that we can get by executing this particular command. So when we execute that manifest file, what it did is it provisioned a lot of resources, right? One of the resources is creating the secrets, and then this is the secret got created. And now what we are doing is just executing this command so that we are reading that secret, and then this is going to decode that base 64 encoded string. Okay, all right. So this is the admin password. Now let's go ahead and access that Argo CD. Since we are forwarding that particular service to the 8080, now we can go ahead and access it. Here 127 and the port number 8080. Okay, fine. We know that it is going to use some SSL, self-signed SSL. This is admin. Username is admin, the default one, and go back the terminal and copy the password. Okay, cool. So now we are into the ArgoCD UI. So usually within this ArgoCD, we are going to create the app. So app is something like the integration. Let's say we are delivering our application, right? Let's go to our whiteboard and talk about what is app more time. So now we are into ArgoCD, right? So within the ArgoCD, we are going to create the apps. So let's say app 1 and app 2 and app 3. Let's assume that we created the 3 applications, right? So app is nothing but the integration, meaning we developed a Django application, right? So Django application is going to some Kubernetes cluster, right? So this particular workflow, whatever we have here, this is nothing but called app one. And let's say tomorrow, if I develop some Go-based language application, and if I have to deliver it to Kubernetes cluster, and then we can call it as app 2. And then app 3, this may be another Python application going to the Kubernetes cluster. So app is nothing but integration. Um, but in the Argo CD terminology, we call those as apps. But app is nothing but this particular integration. Let's say I want to deliver Django to the K8s. We can create that particular application within the Argo CD. And when we create this application, then this application is complete responsibility is make sure always this Django application is up to date on the Kubernetes cluster. Likewise, this app to responsibility is make sure this Go application is up to date on the Kubernetes cluster. And here, make sure this Python application is up to date on the Kubernetes cluster. Okay, now let's go ahead and try this out. And to be honest, we cannot create the application yet because before we create the application, we also need to have another manifest file because when it comes to this integration, right, how we are going to integrate this Django with the Kubernetes. So that with the manifest file, meaning on the GitHub side, we are going to write one manifest file like, this is my application and that this is my deployment and this is my service. So I would like to, I have to write that manifest file. Once I have this manifest file, this app one, for this app one, we are going to tell, okay, this is the GitHub repository and this is the manifest file we have to look up all the time and then deliver this manifest file to the Kubernetes cluster. Okay, now let's go ahead and create one manifest file. Usually we have to separate out our source code with the deployment, but it's kind of preference from one person to another person. But due to the for make it simple, what I'm going to do here is within the development GitHub repository, I'm going to create another folder called installation. And within the installation, I'm going to call another file called manifest.yaml. So this manifest file is basically to install this particular Django application to the Kubernetes cluster. So as we cover a little bit on the declarative language on the GitHub actions, so the good idea is always we go back to the official documentation and get all the YAML files, whatever we need. So in this particular scenario, we required Kubernetes deployment YAML file. So go to the Kubernetes official documentation and go to the deployments and get that simple example. And I think this example will work for us. So copy it. So our manifest file is going to contain 2 sections, one for the deployment and the second one is the service. We will cover what is the deployment and what is service in very high level. Okay, I think this example will work for us. Target port, yeah, I think work. Okay, let's go ahead and copy that guy and drop it here. So before we make any updates on this particular manifest file, let's go ahead and talk a little bit on what is the deployment file and what is the service, something like that. So in this particular scenario, we develop the Django application, right? So if I have to deliver this application to the Kubernetes, I have to create the pods. Let's assume this is my Kubernetes cluster, right? And assume that this is one pod. So pod is nothing but it's a very minimal resource on the Kubernetes, which is going to contain some containers. So in the Docker terminology, Docker or Podman, we call all the applications as the container. In equivalently in the Kubernetes, we call them as the pod. And the pod is nothing but a collection of the containers, or maybe it is going to contain multiple containers. So in this scenario, our pod is going to have only single container, which is my Django application, right? So there is a concept called replication. I'm assuming since you are following this entire series, and I assuming that you are already familiar with some of the terminology. So let's say if I set the replication as 3, that means I'm going to have 3 pods for my Django application, right? So here I will give something like a label as app equals to Django, and the same label will apply here. And this is more like the actual workloads, meaning the Django application is actually running on these 3. But to connect to these applications, there is another service required, right? So this service is going to have connectivity like, let's say port 80, let's assume that a port 80. And how this service will work is by using these labels. So service is nothing but another resource in the Kubernetes cluster. And for any workloads we deploy in the Kubernetes cluster, if we need to access any of these pods, we must create the service. And this service is going to create based on the labels. So here we call this service as service 1 maybe, and service 1. And this service is going to look for the pods using the labels called app equals to Django. And here we are going to do the some port binding. Let's say if I have to bind a port number 80 with some 8080, those type of details, so we define in the service. So again, we are going to have another dedicated Kubernetes series. In that series, we are going to talk about very in detail, like how these pods will work and what is container and what are the main advantages of Kubernetes, and what the services are doing and what type of services are there, and those details we will cover in our Kubernetes video series. For now, I think this manifest file, whatever we have here, this is more than sufficient. And here, let's make a few updates. Since this is Django deployment instead of Nginx, let's give something like Django deployment and app label, app equals to Django. And I'm gonna leave replication as 3, replicas as 3. That means I'm going to have 3 replica pods, and match label here again Django, and Django here, Django and image. And this is where we are going to link our image. So if I go back to the Docker Hub repositories, and this is the image, give that image right here. And then we have to give the tag. Go back, and my tag is version 105. So let's give the version 105 and port number 8000. If you remember, our port number is 8000. Okay, the second resource is creating the service. As we just spoke, this service is going to map with these parts using the labels. And the kind is service and service name. Let's call it as Django service. And then selector, this is where we have to give so that it is going to look for Django, and then it will try to find whatever the Django labels we have, and then it will, this particular service is going to um, at, attach with those ports. And then the port numbers here, 8000. Let's take 8000, and then also port number 8000. Okay, all right. So this is a very simple manifest file. I think our manifest file is ready. Now it's time to create the Django application. I mean Argo CD application. Before we do that, we have to commit this particular manifest to GitHub, because if you remember, we spoke about how Argo CD will work, right? Argo CD, it will look for the manifest file sitting on the GitHub. So now we have this manifest file, and this is committed to the GitHub. Let's go ahead and check our repository one more time. Okay, I have this installation directory now, and this manifest file is right there. Okay, cool. Now we know what are the apps, right? So let's go ahead and create the app. So here the application name, whatever the application name we want to call, we can call that. So Django deployment. Let's give this as the name, and project names, pro project name. Let's give the default one, whatever the default what we have. Just choose that, and sync policy. Um, so this is more like if we let to sync it automatically every 3 minutes, it will go ahead and sync it, or you can also disable the auto sync so that whenever we have to refresh the changes, we have to log in, and then we have to click on a couple of buttons to sync all those changes to the Kubernetes cluster. So for demo purpose, let's leave it automatic. And then these options, I'm going to leave those default. And here, auto create namespace. I, I think it's a good idea to have the namespaces. So let's go ahead and provision the namespaces, because in our manifest file, we don't have any namespaces, right? So let's go ahead and give the namespace. And also here, we have to give the namespace that should be Django app. Uh, but there is something wrong. So here under the selector, the this is more like a key value pair, right? So here for the labels, we have something like app Django, but when it comes to the selectors here, we have something like app Kubernetes IO name, something like that. So we have to match with the what is the labels key value pairs we given to the our deployment, so that whenever the service is running, then it can map with the deployment file or whatever the parts coming out of the deployment file. And also let's fix the port numbers, and the target port number should 8000, which is the container port number. And for the simplicity sake, let's also use the port as 8000 as well for the service. Now I think we are good to go. So now this manifest file is up to date. Let's go ahead and commit the changes. Make the changes to origin and go to our application now. Create auto create namespace, just in case if we don't have that namespace, then it can create the namespace and enable the retry mechanism. Let's say if we have any failures because of any problem, then this retry option is going to retry. And if I set some limit like 2 minutes, and then it can, I mean, if I set limit equals to 2, that means it will retry 2 more times. And this is where we are going to define what is the interval. Okay, all right. So source repository URL here, that should be the repo URL, and use this one, the URL. Here the branches connect to the main, the path. This should installation. Hope this will work. And the cluster. We spoke about Argo CD, right? So natively it is running on the Kubernetes cluster. and whatever the Kubernetes cluster we deployed, I mean, wherever we deploy this Argo CD, that Kubernetes cluster URL is showing up here. But Argo CD has features like if I want to deploy the same changes to the multiple Kubernetes clusters, or maybe if I want to deploy some other Kubernetes cluster, then I can use that some other cluster also as a destination. But when we are talking about when we are going through the Argo CD in-depth tutorials, that time we will talk more about how we can add more destinations and all that. But for now, let's use the default one, and the namespace should be Django app, and this is the namespace. I think everything is okay. So now let's go ahead and create it. And it looks like some sort of connectivity problem. TCP lookup github.com. It looks like unable to look up the GitHub. Sure, if network issue or some ideally. Okay, so now at least something Bash installation is installation. It's right here. Just in app development. Yeah. So I didn't make any changes, but somehow the network problems are resolved. If you see, the deployment is already done. It's like a real fast, right? Because if you remember, the once we created the Docker image, we already pulled the Docker image to the Podman environment, right? So that means image is already there. It's matter of creating the workloads. So if you see here, this is the manifest file what we placed. And out of that manifest file, we have two sections called service and then the deployment, right? A Django deployment. And this Django deployment provisioned three parts right here. So because we define replica equals to 3, that's how we ended up having 3 replicas. But in a very high level, this is the manifest file. Out of the manifest file, I have two resources. One is the service, the second one is deployment. And for the deployment, I have three pods. So everything is showing up in this particular canvas. Okay, all right. So everything is connected. It's a synced. I don't see any problem. Now let's go ahead and verify these changes on the actual Kubernetes cluster. So if we execute something like get ns, it is going to install the namespaces. This is the namespace which is created by the Argo CD. If I list the workloads like kubectl, get pods, -n, Django app, this is going to list out all the pods. Now kubectl get services, -n, the namespace, Django app. So now I have the Django service as well. Now let's go ahead and do the port forwarding, just like how we are doing the port forwarding for Argo CD. We are going to port forward it, and then we can access this application from our web browser. In the production environments, ideally we use the ingress, not just production. In real environments, we will use the ingress or some other load balancing method. But since everything is running on our lab, let's go ahead and use the port forwarding, and don't have the resource because it's 8,000. Okay, all right. Now if I go to the web browser and then try something like 127 and 8081, because 8080 is already forwarding that Argo CD. So now 8081 is going to forward the website. Hola. So now we have the Django application what we built the very beginning of this video course. now that application is deployed to the Kubernetes cluster. Okay, I think we pretty much done with this video series, and all the all the commands and all the necessary details are thoroughly documented in GitHub already. Just to recap, in this particular video, we gone through the CD process, right? So we have some manifest files, and those manifest files are committed to the GitHub, and then we managed delivering this particular application to the Kubernetes using ArgoCD. So this part is completed for the this video is completed for the CD. And in the next video, I'm going to talk about little advanced concepts. I just want to cover the real life scenarios. I understand we already gone through a lot of scenarios here, but I just want to cover one more topic in the next video. So if you don't want to miss out that video, please subscribe to our channel. Thank you. See you in the next video.